Let us consider this simple data set of 5 students and determine whether the GMAT score that they get as a function of their age and the GPA in the undergraduate program. Here we have 1y and 2x. So we'll start by looking at if there any association between the GPA and the score and the age and the score. So for that we will go to data analysis, correlation, and we specify these 3 cells. First row contains the labels, and let's put this output in A8. On computation, we notice that the score is associated with the GPA at 85% and the age is 79%. So there is a significantly strong correlation between the score and the age and score and the GPA. We would ideally not want any association between GPA and age. Otherwise, age could be represented as a function of GPA and that would require a different treatment. Here we are getting it at 37%. We will, and since our data is just very small, we will ignore this or consider this to be unrelated. Now we will build the multiple linear regression model using the regression toolkit. Y is specified by the score, X values are specified by GPA and the age column. It contains the row, the labels in the first row, and let's put the output somewhere in I. Click OK. So now we can read this. We have got the 3 coefficients. Intercept, that's your beta naught. You have beta naught, beta 1, beta 2 corresponding to beta 1 corresponding to GPA and B2 corresponding to the age. We look at the p-values. The p-values of beta 1 and beta 2 are significant, but the beta naught is not significant. So we can consider, let me just conditionally color it, conditionally highlight cells less than and equal to 0.05. Let's make the color to be green. So once we do this, we see that these two are significant. We say that beta naught is not significant, but it is the intercept term or the bias term of the model. So we may consider that, hey, for 0, we cannot trust the beta naught to be minus 44. So except for that, and that in a way anyway does not have any significance for us. We also look at the R square and the adjusted R square. We see that the R square is higher, slightly inflated at about 98%. We deflate it using the adjusted R square to achieve a 96% deflation. And the standard error of the estimated Y is 14. And the F statistic, let me see if I can copy and paste special the format here. Okay, it works. So I can see that this is also significant. So using this, we are able to build a model where we can say that, hey, the age and the GPA determine the GMAT score. Now using this, we can come up with our estimated values of y given these values is equal to beta naught plus beta 1 multiplied by GPA plus beta 2 multiplied by age and enter. So our estimated value is 555, whereas the actual score is 550. I can fill these values under here and determine the corresponding values. I can compute the error here using the formula y minus y hat and when we sum it up, that sum is equal to 0. So we have built a model which is valid. When we do not have these beta 1 other than beta naught betas as insignificant, then we remove that variable and recompute the regression model using the remaining variables. We cannot consider the values derived in the first model to be valid when the dimensions of the model are changed.